You know that sound, that pure, soaring sound of a flute? Ever stop and just think, how? I mean, how does something as simple as a person's breath, just breath, turn into this incredibly complex, emotional music? Well, that's what we're digging into today. We're going to go behind the melody and look at the amazing physics that make it all happen.
Right. So how do they do it? How does a musician take the air from their own lungs and spin it into this gorgeous, intricate melody?
And look, the answer isn't some kind of magic, though it sure sounds like it sometimes. It's actually this incredible dance of physics happening right there at the musician's lips. So let's dive in and see how this whole thing works.
Okay, so it all kicks off with this really basic principle of sound. And what's cool is it's the same idea whether you're talking about a little tin whistle from a toy shop or a massive concert flute up on a symphony stage. It all starts here.
The main idea, the real heart of it, is this thing called sound splitting. Just picture a single stream of air, and it's suddenly forced to make a choice, go left or go right. It has to split into two paths. And it's that super fast back and forth flip-flopping that creates the vibrations that, well, we hear as sound.
So you can see it here. That stream of air hits the sharp edge of the flute's mouth hole. Bam! And it has to split. That vibration, that incredibly fast flicker, that's it. That's the birth of every single note you hear.
But, not all sounds are the same, right? The character of that sound, what it actually feels like, a lot of that is decided right away by the physical shape of the instrument itself.
And get this, just the angle of that cutting edge makes a huge difference. If you've got a really sharp angle, say 30 degrees, like on a lot of European whistles, you get this bright kind of piercing sound. It's sharp. But if you have a wider angle, maybe 45 degrees like you see on many Native American flutes, the tone gets way softer, much warmer. It's a totally different feeling.
Of course, the instrument is just one half of the equation. The player has to get in on the action, controlling their own angle. They have to find that absolute sweet spot, somewhere between a weak, airy whisper and, well, nothing at all. We're talking a game of millimeters here.
So the angle is a big deal, but it's not the whole story. A really skilled player has this incredible second-by-second control over two other things, the power of their breath and the actual shape of it.
This is a great way to think about it. Imagine a garden hose. You know how you can change the spray with the nozzle? That's a perfect way to picture how a flutist shapes their sound. It really is all about pressure and focus.
So first up, you've got airspeed. That's like the water pressure in the hose. It's the engine, basically. And it's what decides the pitch. You want a higher note? You need more pressure. Simple as that. And second, you have the aperture. That's just a fancy word for the opening between the player's lips. This is the nozzle on our garden hose. It's what focuses that stream of air, taking it from a wide, gentle spray to a super tight focus jet. Okay, and this is where it all clicks together in this kind of beautiful golden ratio of sound. If you want a deep, rich low note, you're using slow, gentle air through a wide, open aperture. But if you want a screaming high note, you need a fast, intense, super focused stream of air. It's a totally different physical setup for every single note. It's amazing.
But wait, there's more. There's one last, really subtle piece to this whole puzzle, and it's all about the actual space, the gap between the player and the flute.
Yeah, this is called the strike distance. A good way to think of it is like a runway for the air before it takes off. And the length of that runway, that tiny little gap, it shapes the whole character of the sound before the air even gets to the cutting edge.
So if you get right up close to the edge, the note speaks really easily and you get a bright kind of thin sound. But if you pull back just a tiny bit, the tone gets darker and much richer. The catch? It's a lot harder to control. It takes way more support from the player.
So you might be thinking, how on earth does a professional musician juggle all of these things at the same time? We're talking note after note, phrase after phrase. How do they do it?
Well, the thing is, it's not a set it and forget it kind of deal. It's a constant, flowing dance of tiny, tiny micro adjustments.
Seriously, in the fraction of a second it takes to play one note, a flutist is, without even thinking about it, adjusting the shape of their lips, changing their distance from the flute, controlling their airspeed, and fine-tuning their angle. All of that, all at once, just to create one perfect, expressive sound.
And that kind of brings us to the big question, doesn't it? Is it artistry or is it physics? When a musician masters all these physical laws so completely that it just becomes second nature, pure muscle memory, where does the science stop and the art begin? Or maybe there isn't really a difference at all.